Hello and welcome. My name is Sarah, and today I'm going to cover a few ways to make your enemies in your Unity game move around and make some very basic decisions. So this is a form of artificial intelligence, but it's very, very basic. What we're going to be covering today is AI for beginners. So we aren't going to be doing a lot of the stuff that you think of as AI. We're going to basically be covering 4 different things with some challenge advice that could get you a few more types of AI. So first of all, we're going to make an enemy move in a straight line. Absolutely the most basic thing in the world. There's not really any AI involved there because the enemy's not making any decisions. Then we're going to add a patrol pattern. So the enemy will move in a set pattern, and it will, when it gets to one point, it will go on to the next one. So there's a small amount of decision making there. The enemy has to know when it reaches the point that it's going towards and change to the next point. We'll then have a way for the enemy to chase a player, and that again is a minor amount of decision making. The enemy has to look at where the player is and move in that direction. And then finally, I'll show you how to change between 2 different behaviors, for example, the patrol pattern and the player chasing. And you can also use that to make an enemy just stand still and then chase after the player reaches a certain distance from the enemy. And if the player gets a certain distance away again, you can make this make the enemy go back to its previous behavior. So the first thing we're going to do is the straight line movement. Now, in order to do this, you should already have a few things. You need to have a project already in place. You need to have your player set up and they should be able to move at the very least. And you need to have an asset of some kind for the enemy. So I'm going to be using the tutorial project I have been using for this series of tutorials already. And in this version, I have my player set up. I'm using mobile-based controls, but that does not matter at all for this tutorial. It doesn't matter how your player is moving because your enemies are going to move the same way, whether you're using mobile-based controls, gamepad, keyboard and mouse, etc. It's going to be the exact same for the enemies, so we don't care about that. Mine has these on-screen controls. Yours might not have that. Okay, so what do we do to start off with? We need to actually get our enemy into the screen to do anything with it. So if you have been following my tutorials, you may already have this done. If you did the hazard setup and you used your enemy like a hazard, which is what this spiky thing is. This is a hazard that I already set up. Your enemies are going to be the exact same sort of method as the hazard was to set up. So I'll show you how to do that. I'm going to go ahead and drag this enemy static in because I'm not going to do animations with him today. And drag him into the screen. And I'm going to just change his name to be enemy. So now that I've dragged him in, just to make it clear, you always want to make sure your game objects are named very clearly. Now he has a sprite renderer on him by default, but I'm also going to add a box collider 2D. You can add whatever kind of collider you want, and you don't actually have to have a collider for the purposes of this tutorial, but that's just if you want the enemy to do damage. And I'm going to go ahead and also add let's see, the damage script on here. Well, we'll leave that off for now. The enemy can definitely deal damage to the player, but I'm not exactly sure which script I was using in the previous. Actually, we can just look at our spike. So it's the hazard script. So I'm just going to put the hazard script on my enemy as well here. And I'm going to have it do 1 damage. So when the player touches this enemy, it'll be exactly as if they bumped into a spike or some other hazard, and they will be dealt some damage from that. Okay, now that's not required for this tutorial. I'm just doing it because it makes it a bit more complete and a realistic enemy. What you must add is a Rigidbody 2D, because we're going to be using the Rigidbody 2D to move our object using physics. Our enemy would move using physics. And we're going to use similar settings to the player. So on the player here, I've got a linear drag of 5. I'm actually going to up that on the enemy to 10, because if we don't, the enemy is going to feel he'll overshoot his targets too much. So we're going to up that linear drag to 10 on the enemy. I'm also going to remove the gravity because my game is a top-down game. Now, if you're making a platformer, you could leave the gravity there. But I'm going to remove it on mine, given it's a top-down game. I am also going to go, if your constraints aren't expanded, just click on constraints. You're going to want to freeze the rotation of the enemy because otherwise when he runs into things, he'll start rotating and he'll be a bit weird. So that's your setup done for the enemy. We can now add our new script. So we want to add a brand new script to control our enemy's movement. So we're going to right click on our scripts folder and choose create C# script. And right here, before you go into the script, before you click away, while it's still highlighted, you need to rename it. If you clicked away, you'll need to rename it inside as well. Right, but if you rename it right here, it will automatically rename the inside of the script. So I'm going to call this enemy line movement. Now, it's very important that you do no spaces, and the capitalization is the convention to have a capitalization at the beginning and any subsequent words. So that's why it's the capital E, capital L, capital M. Just a reminder, we've gone over these things in previous tutorials. Okay, so now I've got enemy line movement here, and I'm going to double click that to open it up in Visual Studio. Okay, so this has been automatically created for me, and we're gonna keep the update function, but we're not going to use start. We're gonna use something else, but we're going to get rid of start for now. You can leave the update function because we are going to do something on update. Update means every frame. But before we do that, we need to lay out some variables that we'll need, right? So if you remember from when we did the player click to move in the past, we did something very similar to this. In fact, this is going to use almost the exact same code from the player click to move and player movement in general. So the line movement isn't as similar to the click to move. The patrol will be very similar. But for the line movement, we only need a few things. We need to know what direction we're moving in, and we need to know how fast we're moving. So that's the first thing we're going to do, and we're going to call these public variables. And just a reminder, public variables exposed for editing in the Unity editor. They're used for things like settings for a script. Anything that the designer would want to change regularly. So in this case, we're going to have a public float, and a float is a variable that has a decimal point, right? So public float force strength, that's going to be how hard the script pushes the enemy, aka how fast the enemy moves. Okay, I'm going to make this a little bit larger so that you can see more clearly on the video, and I'm going to just make this indented. You do not have to add all these notes with the slashes. They are just there to help you understand what's happening. Those are comments. Okay, they are not used as actual code. So anything after the slash is not used for actual code. We're going to have another public variable. Remember, these need to be public, so they're editable in Unity Editor. And we're going to call it vector2 direction. Okay, so this variable is what direction the enemy should move in. And a vector2 just means it's going to have an X and a Y coordinate. Okay, now we will need some private variables. Private variables not visible in editor, used for tracking data while the game is running. Right, that's what private variables are used for. So anytime it's not a setting that you need to set ahead of time, instead it's something that you're going to use only while the game's running. That's when you use a private variable. So in this case, we're going to have a private variable for our rigid body. Rigid body 2D. Make sure you put the 2D at the end and make sure it's spelled exactly right, because this is something that Unity has. It's not something we're making up. So we can't just put whatever name we want there. It has to match exactly, and it should turn this nice turquoise color, or whatever yours is. If you have a different setting for your Visual Studio, it might not be the same color, but it should turn a different color anyway to show you that it's matching something from Unity. And we're going to call this our rigid body. Okay, and this is the container for the rigid body attached to this object. And it's a container, right? Which by default, a container doesn't necessarily have something in it. So this is empty right now when we declare it. It's like saying, I've got a cardboard box labeled our rigid body, and only rigid bodies can go in that box, but there's not one in there right now. So this is going to be where we store our rigid body so that we can use it multiple times instead of having to, like, go get it every time from the object. You could go get it every time, but that takes time. It's not good practice. So we're going to do that in the awake function, which we're going to add next. Okay, private rigid body, our rigid body. Right, that is going to be for us keeping track of the rigid body during the game running. Okay, let's add a new function here. So we're going to add the awake function. And it's called when the script is first, when the script is loaded. It's not just when it's first loaded. It's called every time the script is loaded. And we're going to call it, what is when it's first loaded, actually. We can put that in. When the script is first loaded. We're going to say void awake. Just like it says void update down there, void awake. And we're going to have our curly brackets and our normal brackets. So void in this case means there's no return type. This is a function, and functions can give back some information, but this one's not going to do that. And it has to be spelled exactly correctly because this is a built-in Unity function, and Unity will only look for a function spelled exactly like this. So if you spell it any differently, it's not going to work. Capitalization, everything matters here, very important. So you must make sure that's correct. All right, and then here we're going to write anything that we want done like the very first time this script on the game object is loaded up. Okay, so let's go ahead and add, we're going to store our rigid body here. That's the first thing we're going to do. So get and store the rigid body we'll be using for movement. All right, that's the first thing we need to do. So to do that, we're going to say our rigid body. That's saying that variable declared, we're now going to put something in it. So our rigid body equals, so that's taking our box that we declared up here, our box, and we're actually going to put something inside. That's what the equal says. We're putting something inside the box, and that's going to be the result of a function. That function is get component. We're going to use these angle brackets to say what kind of component we want. In this case, it's the same as the type of the box. Our box's type, our variable type, is rigid body 2D. So that's what we have to put here. Rigid body 2D. It has to match. And then we put our parentheses to indicate this is a function, and a semicolon at the end to say that line of code is done. So what this is doing is going to our current object, getting the rigid body 2D component off of our current object, and storing it in this variable, right? So that's just getting it and storing it for later. Now we could do this function every single time we wanted to use our rigid body, but that would not be efficient. What that would do is cause slowdown in our code. And it's not good practice. So what you usually do if you're going to be using a rigid body many times is you'll store it during awake. That's commonly done in Unity. Okay, next up, we have a direction up here, but we need to not trust that whatever designer put that information in did it right. Okay, so the key takeaway here is programmers do not trust designers ever. Okay, so we need to make sure that direction is what's called a unit vector, which means it only has a length of 1, because we're going to use that direction to move our player around. And whenever you do movement, you need to use vectors that only have a length of 1. It's part of the underlying vector maths that I'm not going to get into right now, but it's important to remember. Length of 1. How do we do that? We use a built-in function to Unity. We don't have to do the maths ourselves. We use a built-in function to Unity to normalize that vector, and that means changing it to a length of 1. So we're going to do that down here. We're going to say normalize our direction, and normalize changes it to be length 1 so we can multiply it by our speed / force later. All right, and let's move this onto a new line so it's not so messy. Okay. So how do we do that? We just say direction. That's the direction we already have up here, right? We're using the same variable. And we're going to say it's equal to itself dot normalized. And what that will do is we'll take what's currently in our direction container, right? It's a variable, so it's like a container. It's going to take that out, normalize it, which means change it to length 1, and put it back in the same container so we can use it again. All right, and that means our direction is now all ready to use, and we don't have to worry about that anymore. Okay, we're almost done with this script. The last thing we need to do in update is actually move our character. We're going to move them every single frame. Update happens every frame, so roughly once per every 60th of a second, which means 60 times per second, right? Very often, this update is called. And we're going to move in the correct direction with the set force strength, right? So how do we do that? We say our rigid body dot add force, and then we just multiply our direction times the strength. Okay, so that's a really common way to use your vectors. You usually have a direction and then the amount that you're moving in that direction are separate. So that's what we're doing here. We have a direction and then we have the amount separate, and to combine them again and to use in your force here, you just multiply them. And we're going to do that a lot in this tutorial. It's a very common way to do movement and other things like maybe even projectile firing, stuff like that in games. You keep your direction and your amount in that direction separate. Okay, and that's very useful because, for example, your enemy might always have the same speed, the same force strength, but their direction might change, and we're going to see that in the next script. In this script, they're always in the same direction, so it's not so big of a deal, but you're going to definitely see this in the patrol script and the chase script. We're going to be changing direction all the time, but that force strength will remain the same. Okay, so this is now ready to go. We're going to save that. Make sure you save it. If it's not saved, you'll see a star up in the left-hand corner where your tab is for this script. And we're going to go back to Unity once it's saved. All right, so once it is saved, we're going back to Unity. And from there, just a moment, updating my notes. From there, we're going to attach that script to our enemy because it's not actually on there yet. So I'm going to go ahead and drag my enemy line movement script up onto my enemy and drop it. Now, if that didn't work for you, you might have errors in your console. If you can't see your console, remember you can go up to Window, General, and choose Console, and I would dock it somewhere where you can easily see it. I keep mine down at the bottom. If you had errors in your script, you won't be able to attach it to the enemy, so you need to check your script for errors first. They will be displayed down there very clearly, and it's anything with a red stop sign symbol and an exclamation point, that's an error. If it just has a triangle and it's yellow, it's a warning, and it's not quite as important at this stage anyway. Eventually, a programmer shouldn't leave warnings in their code, but as a beginner, you can maybe ignore them, focus on the errors. They will actually stop your code from running. So if you see errors there, and if you press clear and they don't go away, right, that's an error in your compile time for your script. So you can look at the error very carefully, try to read what it says. Don't just go, error, give up. Read it very carefully. It will tell you what the problem is. It is in programmer speak, so when you're first starting out, it can be difficult to understand. But you can, if you follow along carefully, you can usually figure out what it means, and it will tell you the specific line in your code where the error is occurring. And if you double click it, it will take you directly to your code where the error is. So say I forgot to put this semicolon in there. Notice that's on line 36 in my enemy movement. If I come back here, you can see I have an error, line 36. It expected a semicolon, and if I double click, it takes me right to this spot, and you can see there's a little angry red underline on my actual code as well. And if I mouse over, it says expected semicolon. I can put the semicolon back in, save it, and then my error will eventually go away. It takes a minute to compile, right? Anyway, so once you've attached your enemy line movement to your enemy, you're not done quite yet. We need to set up our force strength and our direction, because remember, we made those as public variables, and that means we set them up in Unity. So we need to actually do that on our enemy. And what it also lets us do is if we have multiple enemies, they can have different force strengths, so different speeds, and different directions they move in, which is important if they're in different locations. So you can use this to make settings that your code is the same for all these enemies, but their settings for those enemies are different, which is really, really useful, because what you do not want is a separate script for every single enemy in your game. That would be horrible, right? You don't want to do that. Instead, we have these settings that let us change for each enemy little things. As long as the overall logic is the same, these little things can be changed, right? Okay, so for this enemy, let's go ahead and change his force strength to 20. And his direction, we'll put a -1 in the X direction. So those of you who remember your algebra, that means he's going to be moving to the left. Okay, so let's go ahead and press play here and see what happens. I expect our enemy should move to the left at a decent speed, and he is. Okay, excellent. So if we wanted to change that so the enemy was also moving -1 in the Y direction, he would move diagonally. And let's see if that happens. Yep. And if we wanted to do +1 in the Y direction, he would move upwards and diagonally. So the takeaway here is that you only need to use one, -1, +1, or 0 in these direction spots. You can use other things if you want to, like say, for example, I wanted to move only a little bit in the Y direction, not the full amount. I could put 0.5 there, and he's not going to move quite as far in the Y direction, right? He's going to move more at a 45-degree angle, right? So you can do that, but you don't have to put like, 100, or it's going to be quite odd then. And it means that his X direction won't be as effective, because compared to this Y direction, it's small. So really, you want to try to use between 0 and 1 in these direction slots. It's going to make you a lot, give you a better result. That's a little bit of a simplification. If you actually understand vector maths, then you don't need me to tell you this anyway. But for those of you who don't want to go there into vector maths, just use between 0 and 1 and adjust them. Remember that they're relative to each other. Okay? All right. So for now, I'm going to make my enemy just go to the left because it's simple that way. All right. That is part 1 done. Let's take a look at, so that's very, very simple. I didn't even cover the action condition for this. Your condition is every frame, and your action is move in the direction. It's very, very simple. You're literally moving every frame, so there's barely a condition at all. The condition is just do it in the update function. Move your character every frame in the update function. Apologize, random notification sounds. So then we are ready to move on to our next script. So that is line movement. And if all you want is your character, your enemy to move in a straight line, that's fine. Now, let me briefly say some challenges that you could add to this. So first of all, say you want your enemy to spawn and then move in a line. You want these enemies to spawn instead of just being already there in the level. If that's the case, it's not too difficult. I would suggest looking back at my tutorial about shooting, player shooting, and that was from previous video tutorial that I did here. And instead of a player shooting bullets, you can have a spawner shooting enemies, but they don't have to have a projectile speed to start with. They just can spawn in. So you can leave out the section that sets their speed. You can make a prefab of your enemy, make them spawn that way, and it should work just fine. The main difference is, of course, you're not using a button to cause that to happen. Instead, you're doing it based on time. But in that tutorial, I also cover how to do things based on time, okay? And so that is what I would recommend taking a look at. If you have trouble figuring out how to do that, you can go ahead and ask me in the comments on this video. The other thing that you may wish to do in this is, if you want something like a Goomba that changes direction whenever it hits something, you could add a separate collider and a script to this enemy, and if it hits a wall, you can make it change directions by getting the enemy line movement script and actually changing the direction variable on it. Okay, so that's the other option that you could use to modify this script to make it maybe a bit better for your game. Okay. We're not going to go over into that in detail, but again, if you get stuck, if you don't know exactly how to do that, you could ask me in the comments for this video. Okay, so let's look at our second type of movement, patrol movement. So for this one, we're going to need another script, and let's briefly go over the differences. So in this, we really have two actions and conditions. So we have the exact same condition and action from our first script. Every frame, move in the set direction. The difference is that we have a separate condition and action condition. If we reach the target action, pick a new one, and by pick we mean go to the next one in the list. So we're going to have a list of targets. You're going to go to the first one first, and then after that you're going to go to each target in order, and then when you get to the end you'll loop back to the beginning. So it's the same as what we have right now, except for instead of a direction, we're going to move towards a target point, and we have a separate condition and action where we need to check if we've reached our target. And this is going to be very, very similar to the click to move tutorial that I did quite a while back, okay? So how do we do this? First of all, we need a new script for it. We're not gonna edit our existing script, we're gonna make a new one, right? And that way, if you wanna use the line movement script, you can still use it. So I'm gonna right click my scripts folder, and I'm gonna choose create, and I'm gonna choose C# script. I'm going to call it enemy patrol. Okay, remember you need to edit it before it goes away, before you click anywhere else, and you should have no spaces, and you need to capitalize your E and your P. Okay, so once you've created that, you're going to open it up by double clicking into Visual Studio. If you see this message, you can usually just click reload solution because I don't have any unsaved changes or anything. Okay, so now we've got the enemy patrol script. So The first thing we're going to do is set this up somewhat similarly to our initial script from last time. And we're just going to make it go towards a single point, and then we'll add the second condition. So let's go ahead and up here in our enemy patrol, we're going to add our public variables at the top. Remember, public variables go inside these curly braces, not all the way up here. They need to go inside the curly braces, but outside of your functions. Okay, so our public variables in this case, we're going to have public, float, force strength, just like in our last one. Okay, and for now, we're going to add public vector to patrol point. And we're going to change this later, but we're going to leave it like that for now. So this is kind of similar to our last one. I'm going to click to our last one. We had a direction. In this case, we have a point that we're moving to, a target point. Okay, so let's go ahead and know what that is. Patrol point we will move to, and our force strength is how fast we move, right? Okay, we will also need some private variables. For now, just one, and we'll add to it later. So we will need our rigid body, just like we did in our enemy movement one, our enemy line movement one over here. We're going to need the rigid body because, again, we're going to be using that physics rigid body to move us. That's how we are going to move. So we will have a private rigid body 2D, our rigid body, and the rigid body on this object used to move, right? That's what it's for. So let's go ahead and remove the start function again. We're going to use the awake function instead. And awake is called when the script is loaded. All right, that's what the awake is, how it works. And the first thing we're going to do is get the rigid body attached to this object for movement. Okay, and to do that, we're going to take, just like we did before, I'm going quickly because this is what we've done previously. If I'm going too fast, pause the video so you can catch up. All right, our rigid body equals get component, rigid body 2D, parentheses, and semicolon. So this is exactly what we did in the last script. No changes here, okay? Then we're going to go down to the update function. And again, very similar to our last script, all right, we are going to move in the direction of our target. And to do that, we need to first of all get the direction. So this is where we have some differences. Before, in our enemy line movement, we just had one line of code and update. We took our rigid body, we added a force in this direction with this strength. Now, we don't have a direction yet. We have a target. So we need to get the direction before we can do that last step. Okay, so get the direction we should move in. And we do that by subtracting the current position from the target position. And that's how you get a direction from one point to another point. You take the target position and you subtract the current position. That's how you get that direction. That's going to be true for basically any situation where you're trying to get the direction from point A to point B. You take B and subtract A from it, and that's your direction. So we do that by saying we're going to declare a variable to hold that direction vector in temporarily. So it's going to be a vector to direction. That's saying I've got a new box. I'm going to put the result in this box so I don't lose it, because we need to make sure we keep track of that result. Vector to direction equals patrol point minus, and we're going to use a vector 2 here in parentheses. Why do we need that? It's because we're going to go get the position from our game object, but when we do that, it comes back as a vector 3 because it includes the depth axis. Now we are using 2D rigid bodies here, so we can't use all three of those points, X, Y, and Z. We don't need the Z, so we are going to use this vector 2 in parentheses that converts the next thing that you write into a vector 2 if it's a vector 3. So we're going to then put transform dot position. Okay, so this will now get the position from our current object, change it into a vector 2, and subtract it from the patrol point. Now there's one last thing we need. So we need to put a parenthesis at the beginning here and at the end, and we're going to do dot normalized. All right, And that will take this resulting vector, which could be, you could be really far away from them, but we don't want that distance to influence how fast you move. You don't want to move faster when you're farther away. Maybe you do, but in my case, I don't want that. So in order to take away the factor of how far away we are from our target, we're going to normalize. We're going to change that vector to only be length 1. Okay, and that's going to make this usable in our last section. Because remember, just as I said, with your enemy line movement, we have to normalize that direction in order to use it in this equation. It must be of length 1. And even if you don't understand vector math, you can just remember, I have to make sure my direction is normalized before I can use it to multiply by a strength and use to set a force or a movement or whatever. Okay, so we've got that now. It's been normalized at the end there. And what does this all mean? Well, basically, we've taken our result and normalized it. Now, if this is confusing for you, you can actually do it the exact same way that we did in our previous one. So you can just set the direction to be equal to that center bit, and then you can say direction equals direction not normalized, just like we did in the previous example. Okay, so you don't have to do it all in one big line if that's confusing to you. This is still the exact same thing that I just wrote. It just does it in 2 steps instead of 1 to make it a little clearer. Okay, last step is exactly the same as enemy line movement. In fact, you can copy it if you want to. It's going to be identical. So what we're going to do is we're going to move in the correct direction with the set force strength. So we already have determined our direction, and we set our force strength way up here in the public variables. So we just move ourselves in that direction. That's all there is to it. So now, if we save this and we go back into Unity, we can take a look at our enemy. Now, the first thing we want to do is remove the old script. We're not going to be using it. So on our enemy, if you scroll down in the inspector, you can right-click enemy line movement and remove component. That'll get it out of there. But we do want to add our new one. So we're going to grab our enemy patrol and drag it onto our enemy, and that will add that. Let's go ahead and set our force strength to 20, just as it was before. But now we need to set our patrol point. So we should look at where our enemy currently is. Mine's at a weird number, so I'm going to change it. I'm going to put him at 1. Actually, I'm going to put him at 3. And we'll put him at y of 3 as well. So he's at 3, 3. Okay? So say I want to move him to 2, 3. Right? Let's do that. So let's put 2 and 3 here. So if 2, 3, 2 is less on the x-axis, so I just expect him to go to the left. So if I press play now, he'll move to the left, and then he just kind of hovers there weirdly and goes back and forth. And that's because he's reached his target. And if he goes past his target, he's going to turn around and go back the other direction. And if he goes past it, he'll turn around and go back the other direction. So we're going to need to do something about that. Okay, so what do we do about that? We need to add multiple patrol points, and we need to add a logic for when he reaches one to go to the next one. So that's the next step to change this script. We've finished action 1. Action 1 and condition 1 are done. Now we need to move on to our second action and condition. And as a reminder, that was action 1 was every frame move in a set direction. We've done that. But action 2, if we reach our target, update to the next target in a list. So what do we need there? A list of targets and a distance for when we've reached the target, and then logic for changing to the next target. So that's the 3 things we need. So let's go ahead and go back to our enemy patrol, and at the top where we have patrol point, we're going to change this. So instead of patrol point, we're going to put a weird square brackets, vector 2, square brackets, and then we're going to change this to patrol points with an S, because the square brackets means it's an array, and that means there are multiple things in that variable. It's kind of like, instead of this being a single box, it's like a box with multiple dividers inside. That's your array. It can have multiple things in it. Okay, so this is a multi-box, if you will, and we're going to just say that can be patrol points that we're moved to. Now we need another thing on this list then. We need a public float, and this is going to be our stop distance. Okay, and this is how close we get before moving to next patrol point. We can't put 0 there because realistically our player or enemy will probably never be at exactly 0 from its target. So instead we're going to use a stop distance to say if we get within this amount, it's close enough and we can move on. Okay? And we made that a public variable so that it can be edited in the Unity editor and changed as needed. Okay, then we're going to need to add a new private variable as well. Okay, so for our private variables, I'm going to add private int current point equals 0. So this is important. It needs to be an int. An integer means it can't have decimal points. And that's because this isn't actually just a number that sat there. This is a index for our list. Okay, so it's basically saying we are currently on the 0th point. What the heck does 0th mean? In most programming languages, when you're looking at a list, you start at 0. It's kind of like the way in Britain, your first floor, in American, I call it first floor, but in Britain, the bottom floor of a building is the ground floor. You can think of it as the 0 floor. And the next floor up is the first floor. It's the same thing here. In your list, the first item is actually the 0th item, and the next item is 1, and the one after that is 2. The reason that that's happening is that it's actually an offset from the beginning. Okay, so the first item in the list has a 0 offset. The second item in the list has a 1 offset from the beginning. Okay, it's how far you have to, think of it as how far you have to travel down the list to get to it. All right, so the very first item, you don't have to travel at all, so it's 0. The next item, you have to travel 1, so it's 1. Okay, so I know that's very confusing when you're first starting out. Just trust me, we're going to start at 0 whenever you're using an array. So let's put a note here, and we're going to say index of the current point we're moving towards. So the way we're going to get this now is instead of having just a specific point, we're going to say, let's go to our list and figure out which number in the list we're on. Okay, we'll start off on 0 and we'll add to this as we move along through our list, right? Okay, so so far so similar. Then we'll see there's a problem here with patrol point. What do we do? Why is it angry underline red? That's because we changed this. So it's patrol points with an S now because it's multiple points, but it's still angry underline red. And that's because we're trying to subtract a single position from a list of positions, and you can't do that. So instead we need to get the current position, the current point that we're trying to move towards. And to do that, you're going to use these square brackets again. And inside the square brackets, you're going to put the index. So in that case, it's our current point. So when we first start off, that's going to be 0. So we're saying patrol points 0. What does that mean? It means go to our list of patrol points and get the 0th item, which means the very first one on the list. Okay? Later, we'll add 1 to this current point, and it will then go up to the next point on the list, and so on. Let's test and make sure we're going okay so far. So save your work, go back to Unity, and you're going to see in your enemy patrol now that there is 2 new things. You'll have this patrol points, which is got a little triangle next to it. You need to expand. And then it says size 0. And then we've got our stop distance, which is also set to 0. So first of all, let's change the stop distance to 0.1 because 0, as I said, is not going to work. But 0.1 is usually big enough to let our logic catch it, but small enough to not look funny. And then we're going to change the size of our patrol points. I'm going to make a 4-pointed patrol point, 4 patrol point patrol for our enemy to do. So we're starting here at 3-3, and the first thing we're going to move to is 2-3, just as we planned in our original attempt earlier. Then we're going to move to 2-2. Then we're going to move to 3-2. And finally, we'll move back to where we started, which is 3-3. Now, right now, our code doesn't do that. Our code will only move us to 2-3, just as we did before. So if you've set this up, and if you didn't get that in time, go ahead and pause the video and make sure you get caught up. Once you've got that set up, if you press play, he'll just move to that first point again and hover. That's fine. We haven't put in the code to make him change points yet. But now we're using a list. All right, so the goal here is that we've now got the same behavior we had before, but we're using our list. Okay, let's go back to our code. Okay, before we change direction, before we use our direction, let's go ahead and see if we need to change it. So in our update, we're going to do our second condition and action. Okay, so our condition here is if we are within a certain distance from our target point. So that's an if statement. Okay, so first of all, we need to know how far we are. We need to know our distance to our target point so we know if we are within a certain amount. So let's do that first. How far are we from our target? Question mark. All right, we'll need a variable to hold this so we can actually use it in our if statements. Let's make a temporary small variable here. Float distance equals, and that's going to be our patrol point's current point, minus, and exactly the same as we have down here, vector to transform dot position. But we can't put that into this float because these are vectors, so we're going to get a vector. What we need to do is put a parenthesis at the beginning and a parenthesis at the end and do dot magnitude. Okay, so what does that mean? That is how big that vector is. So we're going to take the vector that represents between point A and point B, so between our enemy and the patrol point, and we're going to figure out how far that is. And it just uses the Pythagorean theorem to figure that out. So that will get that value, the distance. Once we have that, we need to do our condition. If we are closer to our target than our minimum distance, if distance less than or equal to stop distance, all right, then, and we can put another comment here, then update to the next target. Okay, so how do we do that? We do current point equals current point plus 1, or if you know more programming, you can do plus current point. Okay, so we got a minor problem here though. I'm gonna just head it off, or we can test this. Actually, we can just go ahead and test it, and we'll see what the problem is. So if you save this and test this, what you should have is this guy, and then all of a sudden he gets here, and you get an error. And I see an error come up here. Out of bounds. Index was outside the bounds of the array. All right. Why has that happened? Well, it's because when we get to the end, we were at 3. Because we have a four item array, the last object is index 3. Right? We get to 3, we add 1, and there's nothing else in our array. And the program goes, I can't handle it. It doesn't know to loop automatically. So we need to tell it to loop back to the beginning when we get to the end of the array. So if we've gone past the end of our list, which if our current point index is equal or bigger than the length of our list, if current point greater than or equal to patrol points dot length. Why didn't I just put in the number 4 there, right? We know it's 4 items long. Right now it is, but what if we wanted to have a more complicated patrol that went through more points, right? We need to make sure that we don't assume things that aren't true. So we use patrol points.length to figure out how long it is. Now in my example right now, it's 4, and that's what's going to come through there. So if our current point is equal to or greater than 4, so if it's 4 or 5 or anything higher, then we need to loop back to the beginning. And that's quite easy to do. All right, so we need to then loop back to the start by setting current index to 0. So current point equals 0, right? That's all we have to do. So if our current point is greater than or equal to the total number of points, then set our current point back to 0. So save that, go back to Unity, and what you should see at this point is that it no longer gets stuck at the end there. It loops back around. Right? And now you can make any kind of patrol you want using this code. Okay, Right. So far, so good. That's our patrol done. Now, some of you may also want an enemy that chases the player. The good news is this is very easy, right? We're going to make an enemy chase the player. It's going to be very similar to our patrol code where we have a target point we're moving towards. It's just that this target point will change whenever the player moves, okay? So let's go ahead and make a new script for that. And I'll briefly say this new script, our condition and action is, again, really, really simple. We've gone back to only really having one because this script doesn't make a change when you reach the target. It's just going to stay chasing them, right? So our condition is just every frame, and the action is just move towards the target. It's just that that target maybe has changed positions. But the way we're going to write the code, it doesn't matter, right? It's still going to be very, very simple. So let's go ahead and right-click our scripts folder. All right, if I can right-click the right thing. And we're going to do create C# script again, and we're going to call it enemy chase, right? And I'm going to double click this enemy chase. And again, I'm going to click reload the solution. That's absolutely fine. Remember, no spaces. If you added spaces, you're going to need to remake your script. No spaces in there, capital E, capital C. Okay, so let's take a look at the enemy chase script. First of all, we're going to have some public variables at the top. Public. And then inside there, we're going to have public float force strength. This is getting familiar, right? How fast we move. And then we're going to have a public transform. This is a different one. Target. Transform is a built-in Unity thing. We need to make sure you spell it correctly. It should have a capital T, and it should change to a different color to show that it's recognized that properly. If it can't find it, you'll get a red underline. So this is every single game object in Unity has a transform, and it keeps track of the position, rotation, and scale of that object in the game world. Okay, so what we are going to use this for is we're going to drag in our player into this target transform slot that will open up in our Unity editor, and then we can access that transform in order to change our to move to our player's location. Okay, so let's go ahead and just note that the thing you want to chase. Okay, and then we're going to have a private variable just as we have every other time. We're going to have private rigid body 2D, our rigid body. This is exactly the same in the last, sorry, I didn't spell that out correctly, our rigid body. This is exactly the same as in our last few scripts, right? This is the rigid body attached to this object for movement, right? Same thing that we've been doing with our rigid body so far. Okay, now just as before, we're going to change this to an awake instead of a start. All right, and awake is called when the script first loads. And this is fine to use. It's better to use awake when you're only doing stuff internally with your script. If you're doing stuff in the setup sort of stage with other scripts, you want to use start. So if you're like going and trying to find another script, you wouldn't do that in awake. You would do that in start. That might be a bit advanced for some of you, but if you're moving on to trying new things, just keep that in mind. Awake is if you're doing internal initialization, and start is if you're doing anything with other objects or other scripts, then you use start. Okay, so in awake, we're going to get the rigid body that we'll be using for movement, just as we have in every other script so far. So rigid body equals get components, rigid body 2D. Okay, so this will take our variable that we've declared for rigid body, and remember that's like a box, and we're going to go and get our component from the current object that the script is attached to. So this script that we're writing is attached to an object. It's going to get the component on that object that is rigid body 2D and store it in our box. Okay, so then our update function, very, very simple. All right, this is going to be almost identical to the update that we did in the section for enemy line movement and the original section for our enemy patrol. All right, so we want to move in the direction, our target. And we know that our final bit of code is going to be the same as before, right? We're going to move in the correct direction with the set force strength. by using our rigid body, add force, and multiply a direction times the force strength. What we don't have right now is the direction. So that's exactly what we had in the beginning when we were doing our enemy patrol, and it's going to be the same here. So let's go ahead and get the direction as in enemy patrol. And I'm not going to write out all the same comments, but you can look in enemy patrol to see how that works. And we did that by having a vector 2 direction. And in enemy patrol, that was equal to like our patrol point, right, which we don't have in this one, minus vector 2 transform dot position, okay? And then we did normalized. And that's a Z. And we had a parenthesis there. So this isn't going to work here, though, because we don't have a patrol point, right? And just a note, this thing that says transform, that's the transform that our game object, that this script is attached to. What script is this? It's an enemy script. So that's the enemy's transform, the enemy's position, right? That instead of, what we want here, instead of a patrol point, is our target's transform, which we have, right? We have target up here. So it's going to be exactly the same as this. Okay, I can even copy that. But instead of transform, we're going to put target, because target is a type of transform. So target dot position. And we need this vector 2 because this is actually going to come back again with a vector 3. We do not need that Z coordinate in that vector 3. So we're going to get rid of it and just keep the X and Y. And that's what that vector 2 does at the beginning. So we're going to have our target's position as a vector 2. And we're going to subtract our position, our enemy's position, as a vector 2. And then that whole thing, we're going to normalize. And remember, you could do that in 2 steps if you got a bit confused by this code. Basically, that's getting the direction and then changing it to a length of 1. Once we have that, we're going to move in the correct direction with the set force strength. And again, you can actually copy this from your patrol or from your line movement, because we've named our variables exactly the same way, so it's going to work exactly the same way. If you name your variables slightly different, you won't be able to copy paste, but it should be clear what you're meant to do there. Okay? All right, save that. That should be our enemy chase done. It's not as complicated as the patrol. It's actually quite easy. Okay, let's go back to our Unity. And on our enemy, we'll click on him. We're going to get rid of our patrol. Actually, you know what? Don't get rid of your patrol. We're going to, because I don't want to put in those things again, and we're going to use it. We're going to learn, we can actually just turn the script off, by clicking this tick box, right? This tick box next to the name of the script. You can turn the script off. So just turn it off by ticking it. And once you've done that, it won't run anymore. So if I press play, my enemy's not going to move at all because his script isn't on, right? So then we can add our enemy chase to our enemy. And why I keep both on here is because the last thing I'm going to teach you is how to switch between scripts, between behaviors. Okay, so you need to leave them both on there. Okay, enemy chase. There we go. So we need a force strength. Let's just put 20 again, same speed as before. And let's put a target. We're going to drag our player. Oops, sorry. Select the enemy, drag the player. Oh, now look what I've done. Got to scroll down to where the enemy chase is. Drag the player into that slot. Okay, so you've dragged your player into your enemy chase target position, and now it should say player. If you don't like dragging it, you can always click on this circle here and choose the player, or you can always just type in player and it'll show up. Okay, so we've got an enemy inside your enemy chase there, and if we, a target inside your enemy chase, if you press play, your enemy will now move towards you, and if you move around, your enemy should correct for its position. He'll kind of go off the screen a bit, but he'll come back, and he'll come to you, and eventually, I'll just die. I was stuck between spikes and an enemy, so that's fine. So that is enemy chase, all working properly. Okay, simple. Next and last, I'm going to teach you how to do enemy AI based on how far away the player is. It can choose a behavior. But before we go there, I want to briefly say, if you are using the enemy chase and you are trying to add the ability to spawn enemies, you will encounter a problem because your enemy can't have a reference to the player like this without being set in the scene. right? If it's spawning in, it won't have a reference to the player. So you would want to use a function in the start function for your enemies chasing to find the player, okay? And that would be the find object with tag function. And you'll want to put a tag on the player, and that's done up here, and you can choose tag, and player is one of the default tags. So you can just set the tag to player, and then whenever your enemy is starting up, it needs to look for the object that has that tag, and then it can store that in its target. Okay, so it's a little bit more complicated. I would say look up that find object with tag code and see if you can sort out what to do. And if you need help, as always, you can ask in the comments below. Okay, so I'm going to clear this error that popped up on my guide died. So that's how you'd modify that if you were using object spawning. Let's take a look at changing our enemy based on distance, changing the behavior. So what we're going to be doing here, we have a condition when the player is within a set range, and then we have an action, change to a different behavior. And we're going to change that behavior by just turning on and off the scripts. We saw that if we have turned off our enemy patrol, we don't get that behavior. And so only the one that's on is the behavior you get. And you can test this. If you press play and you have your enemy selected and you've gone down to where the enemy patrol is and the enemy chase, you can press play. You can turn off enemy chase. Turn off enemy chase and turn on enemy patrol. And he's going to go back and start patrolling just as if he was always in that spot. Then you can turn off enemy patrol and turn back on enemy chase. And you can turn off and on enemy chase, and you can turn off and on enemy patrol, and you'll see that they can just carry back on to where they were before. All right, so you turn that off there, you turn this on, you turn that off, you turn this on. You can see he just goes back to where he was. So it's really easy to swap between those, and you can do that in code. Obviously, you're not going to be doing it manually because you're not going to be there with the person that you're having play your game. You can do that in the code based on some condition, and our condition is going to be whether or not the player is in range, in a set range. So let's go ahead and add a new script for that. We're going to right click our scripts. You're going to do create C# scripts, and this is going to be enemy distance decision. It's kind of a rubbish title, but you can call it whatever you like as long as there's no spaces and that you capitalize the correct letters. Okay, so go ahead and open that up once you've created it. And inside here, we're going to have a few things. So first of all, we need some public variables at the top, right? Public, editable in Unity. And that's going to be public float distance for decision, right? What does that mean? How close the player must be to change behavior, right? And then we need a public transform target. This is exactly the same as enemy chase. And we're going to use that because just like an enemy chase, we're looking at moving, we're not moving towards a target in this distance decision, but instead we are going to use that target to find out how close we are, just as we did in the enemy patrol, right? So we're going to combine some things from these two scripts. Okay, and then we're going to have private, and we're going to have a variable called for enemy patrol. All right, and we'll explain this in a second here. Enemy patrol, and we're going to call it patrol behavior. And then we'll have a private enemy chase behavior. Okay, so this is going to take our patrol behavior and our chase behavior. And what does that mean? What does it mean that we have a type enemy patrol and type enemy chase? This means we're going to have references to the scripts that are attached to our object. So it's kind of like having the phone numbers for the scripts or like their addresses. And what we can do, because we're like important, is we can just turn off their phones or their address, whenever we want. So we're going to have references to those. And this is going to be the patrol and chase behaviors that are attached to scripts that are attached to the same object, right? So our enemy. Okay. So we can put a note, and let's see, we'll just go down here to awake. So the first thing we need to do is just as we did in our previous ones, in our chase, and everything else where we're getting our rigid body. In this case, we don't have a rigid body. We're going to use the exact same method to get our patrol and chase behaviors, because a rigid body is a script. Essentially, it's a component, just like our scripts. So the way that we got it, we can use that exact same method to get our chase and patrol behaviors. So let's go back over here, and we're going to change this to awake, because we're dealing with internal things, so awake is better. Okay. And the object loads. All right. And in awake, I'm just going to paste that. This is the exact same thing, but instead of our rigid body, we're putting it into patrol behavior. And instead of the type being rigid body 2D, it's going to be an enemy patrol component. And let's put a note here. What are we doing? We are get the behaviors so we can turn them off and on. That's what we need them for. And let's just copy this. And again, we're going to put chase behavior and enemy chase. So we're going to get these two components off of our object and store them so we can use them. Okay, right. Once we've got that, we're going to turn off the chase behavior to start with. Okay, so we do that by saying chase behavior dot enabled equals false. That's how we turn them off and on, right? So remember that dot means go to that thing. So we got chase behavior, go to it, set the value for enabled to false, meaning not enabled, disabled, right? So that will turn off that behavior. Nice and easy. And we're going to do that to begin with. So the whole idea here is that our enemy is going to patrol until the player gets within a certain range, and then he's going to start chasing the player. Okay. Excellent. So now in update, we need to add some things. So first of all, we need to check our condition. Whenever we set out here, our condition was if the player gets within a certain range. So that means we need to know how far away that player is. We're going to use the exact same stuff that we did in enemy patrol. In enemy patrol, we had how far are we from our target, and we used this distance thing. So I'm going to copy that. How far are we from our target? And instead of patrol points here, we don't want patrol points. We want to use our target's position. Where did we do that? In enemy chase. We have the target's position just here. All right, why am I copy pasting all this? Because I want you to see that you can use logic that you figured out already in previous scripts, in your new scripts, in new ways. Okay, this isn't just, if you had to learn how to do every single thing from scratch every time, you would never be able to finish a game, right? What you need to start thinking about is that the things you're learning can be used in other situations. It's not like a script is just one time through and it's only for that situation. You can use parts of it in other situations. So here, we already know how to get the position of our target because we used it to get that direction in enemy chase. So instead of using a patrol point for the position, we're going to use the position of our target in our enemy distance calculation, right? So what is this doing? Let's just summarize. We're getting our target's position as a vector 2. We're subtracting our enemy's current position as a vector 2. And then we're getting the magnitude, which means how far away those things are. And we're storing that in our distance variable. Okay, what do we do with that? Now we have our condition. If we are closer to our target than our minimum distance, we use our if distance less than or equal to distance for decision. So if we've gotten close, then we need to disable patrol and enable chasing. Okay, so patrol behavior dot enabled equals false, chase behavior dot enabled equals true. Okay, so what this will do is whenever we get close enough, our enemy will start chasing us. Okay, now I'm going to add to this in a minute, but I want to show you what this looks like so far. So save this, go back to Unity, and again, if yours didn't compile, pause the video, check why, sort out your errors, then come back. So assuming this all worked, we can now attach our enemy distance decision to our enemy, right? You need to attach that script first. And then once you've attached it, you need to set a distance to decision. I'm going to put 3. So if our player is within 3 unity units then of the enemy will start chasing them. It's up to you what you put there, but I would make it, 3 works pretty well with my current scale. Then I'm going to drag the player into the target slot so that the enemy distance is based on how far the player is away rather than not some other object, right? So we do have to have player as a target in 2 different scripts there. Okay, so now if we press play and I move towards the enemy, the enemy should start off. See, I have a problem here because both of my scripts are turned off. So let's turn on the enemy patrol. All right, so I've got my enemy selected. I need to turn on the enemy patrol. So now if I press play, my enemy should start off by patrolling. And then if I get close, I'll get closer over here. Okay, he's chasing me now. Now the thing is, he'll never stop chasing me. So if you want him to never stop chasing you once you get close, that's fine. But if you want your player to be able to get away and the enemy to kind of lose interest and go back to where he was, you can set that as well. Okay, so if you go back to your script, we can just put an else here. What does else mean in an if statement? It means that if this part's true, this section is going to happen. If this part's not true, the else is going to happen. So if we are not closer than our judgment distance, basically, if we are farther away than our judgment distance, then we will do the stuff in the else section. So we're going to say enable patrol and disable chasing. So patrol behavior dot enabled equals true. Chase behavior dot enabled equals false. So this means that we will stop chasing and start patrolling again whenever we are within, farther away than that amount of distance. Now you could have a separate distance for that instead of using the same one. So there's maybe a bit of a wiggle room. So you have to be farther away than that initial distance for that enemy to lose interest in you. That's quite possible. But for now, we are going to leave that alone. So if I go down here now, if I press play, my enemy I've saved it, by the way. Make sure you've saved it. My enemy starts off patrolling. I'm going to go over to him now. And he started to chase me. I'm just going to run off the screen. But I've run far enough away that he's gone back to patrolling. And I can go back over to him and then get hit and get killed and run away. Yeah, so he's gone back to patrolling. So you can see that this is working both directions. He starts chasing when I get close, and he goes back to patrolling whenever I get far enough away. All right, so that is the basics there. Some challenges and changes you could make. First of all, you could make your enemy do nothing to start with. He could just be sitting there, and when you get close enough, he starts patrolling. Okay, so to do that, you would just not have that patrolling one and just turn on and off chase. Okay, so that's all you'd have to change there. Quite simple. This will not work with spawning as it is. You'd have to do the same thing I was describing for the previous script, where when it spawned, it would have to use find object with tag in the start function in order to find the player and put it in the target slot. So if you're using spawning, that will be needed. And finally, just in general, one of the behaviors you might want to have, instead of making it chase the player, maybe you want your enemy to start firing projectiles at the player. Now you could do something really similar to how the player projectile firing works, which I covered in a previous tutorial, and simply turn that on and off, just like we did with our movement, and make that fire projectiles there. The main difference is that rather than doing it based on a button, you can make it do that based on a time. And if you just disable the script, that will be disabled and it won't check the time anymore, and it won't fire projectiles until it's enabled again. Okay, so just as I mentioned earlier about having a projectile script, you could do that with this turning off and on behavior as well. Again, if you struggle with any of those challenges that I haven't covered in detail here, just go ahead and ask questions in the comments below, and I'm happy to help you out. I hope this video was useful. This stuff is obviously starting to get more complicated, and the more you go into AI, it's going to get more and more complicated. I will give you a caution right now. This AI will not avoid obstacles. So if you have a maze type scenario, and even if your guy is set to chase, he'll just run into a wall. All right. Obstacle avoidance, pathfinding, that's a lot more complicated. It's much more complicated than what I'm going to cover here. It's more complicated than a beginner would really be able to do. Now, that said, there are a lot of pre-made scripts out there, and even Unity has things like nav meshes that can make that a bit easier for you. But for your first game, I'd recommend just avoiding it and trying to design enemies that don't need obstacle avoidance to start off with. Okay? All right. Thank you so much for watching. I really hope this helped you out. As always, if you're stuck, just leave me a comment below and I will get back to you as soon as I can. And good luck making your game. Bye.